This week, the UN Climate Change Conference has been happening in Bonn. This meeting is the next step for governments to implement the Paris Climate Change Agreement, which entered force last November, and it sets out strategies to try to limit the rise in global temperatures to below 1.5 degrees Celsius. With these targets in mind, researchers the world over have been exploring various ways to reverse global warming. One suggestion is to spray about 5 million tonnes of reflective sulfur particles into the high atmosphere to temporarily reduce the intensity of sunlight and cool things down. Scientists at the University of Exeter have plugged the proposals into a complex climate simulator to find out what the consequences might be. Jim Hayward.
This particular aspect that we were looking at was injecting sulfur dioxide into the stratosphere, where it forms little particles up in the high stratosphere that reflect sunlight back out to space and leads to a cooling of climate. This is actually basically a direct analogue of volcanic eruptions. The last big climatically important volcanic eruption was in 1991, Mount Pinatubo, and the Earth cooled by around about 0.5 degrees for a couple of years.
And where you're coming from is saying, well, okay, so volcanoes can do this. If we were to do the same, what might be the consequences? Because that's critical, isn't it, to know actually if we do this, what might happen and where?
Yeah, absolutely. And we were particularly interested because there is no governance on solar radiation management. What could happen if one country or one particular player injected aerosol basically above it as a sun shield? What you tend to find is that the aerosol stays in the northern hemisphere if it's injected in the northern hemisphere, or in the southern hemisphere if it's injected into the southern hemisphere. And that can have some big consequences, both on Sahelian drought and also hurricanes. So what we were interested in is really finding out the impacts of unilateral geoengineering.
How? Because obviously you're not going to go out there and do the experiment yet. So how have you done this?
Yeah, well, what we're using is a climate model, basically development of the weather forecast model that is used by the Met Office. We can also use them to investigate things like if we were to deliberately inject sulfur dioxide into the stratosphere, what would those impacts be? There's quite a lot of evidence from the previous volcanic eruptions. There was a particularly nice one in 1913 in Alaska. And because this was at extreme northern latitudes, the resulting aerosol was confined just to the northern hemisphere. The year after that, there was record low river flows in the Nile and the Niger, so there was big evidence of a drought in the Sahelian region and sub-Saharan Africa. Conversely, there was also not a single North Atlantic hurricane, and that's the only year that that's happened. Our models tend to suggest the same sort of thing. If you inject in the northern hemisphere something called the intertropical convergence zone, which basically holds all the monsoon rain, that is deflected down to the south, so that leads to a drought in the sub-Saharan Africa. But you also find that there's a big reduction in hurricane frequency.
So is the way you're doing this, you're taking the way that we understand and we model weather systems, and you're saying, well, let's notionally pretend we've put some particles into this bit of the atmosphere, so therefore we can model how that affects the incoming solar energy, how much the sun's warming the air there, and then you look at the knock-on effects, like the domino effect, through the atmosphere, and then ask, how will that have an effect elsewhere across the globe, were that to happen?
Yeah, absolutely. If you reflect sunlight back out from the northern hemisphere, you cool the northern hemisphere, you change the flow of energy in the atmosphere and the ocean, and that's what leads to changes in Sahelian drought and the precipitation, rainfall associated with the monsoon circulations, and also changes hurricane formation.
Now, you've mentioned that if you inject these particles above one hemisphere, they tend to stay put above that hemisphere. Well, what would happen then if everyone signed up for this and the southern hemisphere did their bit, the northern hemisphere did their bit, so everyone put some particles into the atmosphere, so we get a sort of global cooling?
Yeah, well, under that scenario, the hurricane frequencies and the Sahelian drought actually are not increased. What it's really getting at is that you've got to have some sort of global will and some regulation so that this sort of thing is not done just by one individual actor, but is done as a global collective.
So, bottom line then, Jim, what do you actually think of the proposal? Do you think it's actually got legs?
I think it's important to know what we've got in our tool bag should global warming get very, very desperate. Our climate model is suggesting that global temperatures will warm by around about 4.5 degrees by the end of the century if we don't do anything about curbing our emissions. Places like the Amazon, under these scenarios, warm by 8 degrees, and therefore we're not sure whether the Amazon is resilient enough to deal with that kind of temperature change. So I think it is necessary to know what tools we've got in our tool bag should the situation become critical.
Jim Hayward and his analysis of that so-called geoengineering strategy to reduce global warming came out this week in Nature Communications.